lithium-ion battery. So basically in the lithium battery we are using the partial two-dimensional model, use the P2D model, we called it P2D model. And in this section we have used the lithium-ion battery as well as the finite volume method. Accordingly, introductions like how lithium-ion battery works according to state of charge, state of health, and the battery management system as well. So all the things like equivalent circuit models, electromechanical models, all the things are added in this paper in details. You just read it and you will understand like how current progress in full order P2D models solvers are added. So these are the tables used for the parameters solved in our project, and the contributions like how we just taken the research review papers according to different research papers, and how we take the input from different research papers through MATLAB solver code, and then we just used our full order P2D model, used our kinetic limit and diffusion limited models. The electromechanical thermal P2D battery model is used in our case, which used anode negative electrode, the separator, and the cathode as a positive electrode. So the P2D models considers like these kind of the lithium-ion battery. Here is the cathode, use the red circle dots, separators as an insulator, and anode considers as green bubbles. It means that it provides the charge from cathode to anode basically. So the thing is that this one figures provides the total number of points, like how these donate discrete points from coarse mesh system. Electromechanical thermal model equations used in our case. Basically, the first model was proposed in 1993 by the Newman group. So the thing is that, but in our case, we have used the complete electrolyte phases of the cell, which is basically P2D model applies to both solid and electrolyte phases basically. Okay, so that's why the conversion of mass electrolyte phase of the model is characterized by using the concentrated solution theory. Okay, so I have added the table 2, which provides the complete differential equations, boundary conditions of the Ohm's law, electrolyte phase, Kirchhoff's current law, Kirchhoff's voltage law, thermal energy balance, redox reaction, exchange flux as well. So after that, I have explained like how these complete equations are applied on our P2D thermal lithium-ion battery as well. Okay, so the P2D model also represents the physiochemical process occurring in the cell as independently occurring in it in two phases basically. The first phase basically provides the Blatter-Walmer, and the second phase is redox reaction. Okay, so in the exchange flux is basically the main key for the solving of P2D model. In the exchange of flux, it means the redox reaction occurring at any point, but it also related to spatial derivative of ionic and solid phase currents as well. Okay, so I have added the SEI growth models, which is basically used for the LIB multiple different degradation process, and these equations use like solvent, its positive electrode, its negative electrode accordingly. These are the mathematical like chemistry equations used for our model, and these are the diffusion limited SCI growth according to lithium-ion battery, basically kinetic limited SCI growth as well. So these are the reaction model explained in here, diffusion limited reaction model, as well as the SCI thickness, resistance, capacity, loss. All the equations and its complete description are added in this paper. So you just need to read that paper and you will understand like what is happening in our case. Like finite volume method, basically this also used for our PDA discretization basically. So in all the equations and its used parameters are added in this section. And yes, table 4 is provided the electromechanical thermal models, discretized boundary conditions, basically solid state equations, and the other Kirchhoff's current law, redox current law, basically. Okay. So in the solver algorithm, we have added the complete flow diagram, like flowchart, how solver algorithm works according to A and B. It means that we have used the equations used in our solver algorithm, iterative solver and flowchart of electromechanical edging model algorithm. Yes, table 5 is basically provides the complete parameters, description, anode separator, values of cathode as well, units, everything added in this section. Okay, so all the equations, hybrid root finding algorithm, equations, basically this complete project was based on the mathematical equation solver. So we have added the complete discretized equations of P2D model in MATLAB and we get the output results like this is a cell voltage, this is a cell temperature, these are the complete lithium con contamination basically, this one, concentration basically, okay. According to different times, these are the output as well as results of lithium solid average concentration and the lithium surface basically as well. I have explained everything in the figures form. Tables for the percentage as well as the, yes, these are the as well cell temperature, cell steady state charge, and the anode heat generation as well as cathode heat generation. All the graphs are added differently and separately and explained very well in this paper. Okay, you will understand better what is happening in this complete paper and how the cell voltage, cell charge, cell temperature, cell its internal temperature, its separator temperature, how cathode works, how anode works, how separator works. Okay, so all the drive cycles are provided accordingly, the current and its voltage and the power of the battery as well. Okay, yes, table 8 as well, the simulation speed P2D solver as well. Okay, so I think it is completed now. Yes, conclusion and references. Let me just show you the MATLAB files as well. These are the MATLAB files provided in form of different results, but I have just added the output results accordingly. So basically the thing is that it takes much time to run the MATLAB models. That's why I have added the complete output results for you to explain in the video. Okay, if you need to ask anything you can just ask me, but this is the complete output results. Okay, thank you.